All right, so you should be completing these notes on paper so you can have an easier time watching the video and following along. We will be applying what you guys take notes on today to our notes on Monday. So for your warm-up, you're going to find the length of the diagonal of a square with the given perimeter. So some things to remember about our diagonals of squares. So if we draw out our square, we know that the diagonal goes from vertex to vertex and that we have right angles in the square. I want you to take a moment, pause the video please, and try and do any other labels that you need to on the diagram to be able to solve. So pause the video, try example A, then come back to check to see if you got it. All right, so hopefully you were able to work through that one. So if a perimeter of a square is 40, we know that every side is going to be congruent. So each side, well, 40 divided by 4 is going to be 10. So we can list that all of these side lengths here are going to be 10. What we're trying to find now is the length of the diagonal. So we have an x there. Right away, or you probably already solved it, you're thinking, I can use Pythagorean theorem to solve for x. Because we have 10 squared plus 10 squared equals x squared, which is 100 plus 100 equals x squared. X squared equals 200. We square root both sides, and you get x equals 10 root 2. Awesome, so the length of my diagonal there would be 10 root 2. Now, in situation B, if you haven't had a chance to try and solve it and set it up, please pause the video and do so. All right, again, we're trying to find the length of some diagonals. Since we called the other one x, let's call this one c. We know all sides are congruent, and in a square, our interior angles, each one of them is 90 degrees. So if my perimeter is 4x, we know that each side is going to be 4x divided by 4, which is just x. So we can label accordingly. Just like we did in the previous problem, we can use Pythagorean theorem to solve for our diagonal. So x squared plus x squared, that'll simplify to be 2x squared equals c squared. If we square root both sides, well, we can't take a clean square root of 2, but we can take the square root of x squared. So the square root of x squared, which will just be x. So my diagonal in this situation, the length will be x root 2. All right, take a moment. Please read through the next example of your warm-up. Try and complete it. So pause your video. All right, hopefully you were able to work through A and hopefully B. If you haven't tried B as well, please pause the video and do that. So find the length of the altitude. A reminder that the altitude is perpendicular to the opposite side. Of an equilateral triangle with the given perimeter. So we know equilateral triangle with the length of an altitude is going to make two congruent triangles by angle, angle, side. So let's go ahead and draw out this situation. So we have a triangle. We know it's equilateral. We know all these sides are going to be the same. We have our altitude, which we're trying to find the length of. We know it intersects perpendicularly. And we know this whole side is equal to the other ones. So if my perimeter of an equilateral triangle is 24, we can split it into congruent parts. So each side will be 24 over 3, which is 8. So we know this is 8. This is 8. Think about it. What else can I label? Oh, well, if I know I have, it looks like an isosceles triangle, but it's equilateral. Across from my side 8, this angle is going to be congruent to this angle, meaning this angle is congruent to this angle, making congruent triangles, which means this portion here is 4, and this portion here is 4. So if we call our altitude in this situation b, well, we know 8 is our hypotenuse, so we have 8 squared equals 4 squared plus b squared. This simplifies to be 64 equals 16 plus b squared. When we subtract that over, we get 48 equals b squared. As always, we take the square root of it. How can I simplify that? Well, that simplifies to be the square root of 16 times the square root of 3, which simplifies to be 4 root 3. Again, if you haven't had a chance, please pause the video and try and do B. If you're watching, that means that you were able to get this done. So again, equilateral triangle, every side is congruent. So you do 6x divided by 3, which is 2x. If we draw in that altitude, it'll intersect perpendicularly. We know this whole side will be 2x. Because of our congruent sides, we know these angles will be congruent, forming two congruent triangles, meaning that this will be x and this will be x. If we want to solve for, let's call the altitude m, we can again use Pythagorean theorem by saying, in parentheses, don't forget this, 2x squared equals m squared plus x squared. So 2x squared simplifies to be 4x squared equals m squared plus x squared. We subtract over our x squared, and we get 3x squared equals m squared. We take the square root of both sides, and m is equal to, well, the square root of x squared is x. We can't take the square root of 3, so x root 3. So that was that altitude that we were solving for in each situation. You might be wondering, why are we doing this? It seems like we've already done something similar. Well, the reason is because that leads us into what's called special right triangles. So the first special right triangle relationship we're going to talk about is an isosceles right triangle, which is called a 45, 45, 90. Above, we had drawn a square and solved for the length of the diagonal. So if we think about a square, we know that the angles are 90 degrees. We know that all sides are congruent and the diagonals bisect each other. So looking at this is what creates and why a 45, 45, 90 triangle exists. So if we take what we did in the prior situation, we have are congruent sides. We know that that angle is 90, that these angles have to be congruent, so they'll be 45 degrees. And above, I said, okay, if I called this x and this x, oh, in that situation in 1b, the distance of that diagonal was x root 2. This is the relationship that you're going to have in special right triangles. So the sides across from the 45-degree angles is what you call x. The side across from your 90-degree angle, or your hypotenuse, will be x root 2. So if you take a look at example 1a, I have a 45, 45, 90 triangle. So some things I would mark. Well, I know this angle must be congruent to this angle, which means this side must be congruent to this side. All right. If we call the sides across from our 45-degree angle x, this would be x, and a would be equal to x. Well, since we know a and 9 are across from 45-degree angles, that actually means that a is equal to 9. B is across from our 90-degree angle, so it's our hypotenuse. So this is what we call x root 2. Well, we know that 9 is equal to x, so B is equal to 9 root 2. What I want you to do now, please pause the video and attempt example B and C. All right, if you're watching the video, that means that you had a chance to attempt. Right now I see that I have two congruent legs in a 90-degree angle, meaning that this angle has to be 45 degrees, and this angle has to be 45 degrees. In a 45, 45, 90 triangle, like we have above, our hypotenuse is what we call x root 2, and the sides across from our 45-degree angles, or our legs, is what we call x. So in this situation, we can set 12 equal to x root 2. Oh, but that's not nice and clean, so off to the side we can solve. So 12 equals x root 2. To get x by itself, we divide both sides by the square root of 2. This means we have x equals 12 over the square root of 2. We want to rationalize that denominator. So to rationalize the denominator, you say multiply top and bottom by that square root, and you get 12 root 2 over square root of 4, which is just 2. This whole thing is going to simplify to be 6 root 2. We just solved for x there. We know that the legs of a 45, 45, 90 triangle is what we call x. So in this situation, we can say that C is equal to 6 root 2 and D is equal to 6 root 2. To double check to see if that solution works, you can say, okay, is 12 equal to 6 root 2 times root 2? We plugged it into there. So 6 root 2 times 6 root 2 is the square root of 4, which is 2. And yes, 12 does equal 12. All right, for C, take a moment. Look at those special right triangles. So in this situation, I see again that this is 45 degrees, meaning that if this side is 8, this side must be 8. Well, like we always say, is my legs is equal to what we call x, and your hypotenuse is what we call x root 2. So we know that x, or our legs, are equal to 8, meaning that E must be x times the square root of 2, which is 8 root 2. Now, the difference here is that we now have two special right triangles. So if we draw this special right triangle off to the side, we know that my hypotenuse is 8, that I have congruent legs, and 8, let's use a different variable this time, is what we call y root 2 because it's our hypotenuse, which means that these are just going to be our y's. Well, to solve, we know y root 2 is equal to 8. So to get y by itself, we divide both sides by the square root of 2, which simplifies to be y equals 8 divided by root 2. We have to rationalize that denominator, so multiply top and bottom by the square root of 2. We get 8 root 2 over the square root of 4, which is just 2. So our final answer will be 4 root 2. So in this situation, E is equal to 8 root 2, and F is equal to 4 root 2. Awesome. If you have any questions at this time, please just jot them down so you can reference them when you come to class. All right, the other special right triangle is what's called a 30, 60, 90 triangle. And like from our warm-up we drew above, it comes from half an equilateral triangle. So if I draw in my altitude, we know that intersects perpendicularly, and we know that these angles will be congruent because we know all sides are congruent, and in turn, those sides are congruent. So what that gives me is a 30, 60, 90 triangle. So if we look above, we know that all angles in an equilateral triangle are 60 degrees. So this would be 60, 60. So I can call this angle here 60 degrees. And if I have an angle that's 90 and an angle that's 60, what I'm left over with is a 30-degree angle. If you look from above at our warm-up, we can see that our altitude in situation 2b ended up being x root 3, and the angle, or the side across from our 30-degree angle, ended up being x. So we're going to use that reference here. If my hypotenuse is 2x, the side across from my 30-degree angle is x, we got that the altitude was x root 3. So these are going to be my comparisons for a 30, 60, 90 triangle. Something to remember is that the largest side will always be across from the largest angle, and same for medium and smallest. All right, so let's take a look. For example 2a, if you want to try it out, see if you can do it. If not, you can follow along. I see a 90-degree angle. I see a 60-degree angle, which means that this has to be a 30-degree angle. So we said that the side across from 30 degrees is what we call x. The side across from 60 degrees is what we call x root 3, and the side across from our 90-degree angle is 2x. Well, we're given our hypotenuse, so let's use that hypotenuse to solve for x. So we can say that 2x is equal to 12 because that proportion will hold true. If we divide by 2, we get that x is equal to 6. Well, if you look, that gives me what my a value is going to be. So a is equal to 6, which if a is equal to x, that means for b, it will be 6 root 3. So take a moment, try the next example on your own, see how you do. All right, we have a 30, 60, 90 triangle. Again, let's set up those proportions. This time, we're given the side across from my 60-degree angle, which is what we call x root 3. So, or in this situation, let's call it c root 3 because c is the x. So, c root 3. All right, let's take a moment in this situation to now solve for c. We know that 15 is equal to c root 3 because it holds true to that proportion. If we divide both sides by the square root of 3, we get c equals 15 over the square root of 3. We have to rationalize that denominator, so we multiply top and bottom by the square root of 3. This simplifies to be 15 root 3 over 3, which 15 divided by 3 is 5 root 3. So we have that c is equal to 5 root 3. We also know that the hypotenuse is equal to 2x, but in this case we're calling it c, so 2 times c. So what we do here is we see d is equal to 2 times 5 root 3. So d is equal to 10 root 3. Obviously, pause the video as you go if you need to catch up. If you want to pause and try other problems, you're more than welcome to. All right. Hopefully you had a chance to try C. If you didn't, pause the video and attempt it. Again, let's take a look. I see 30, 60, 90 triangles. So let's start our labeling. Oh, you should have a root 6 here. It should be visible. So if you didn't have that, please label it on your diagram. All right, so we have a 30, 60, 90 triangle, so 30 degrees here. F is what we have across from our 90-degree angle. So let's take a look. So across from my 60 degrees is root 6. So this is our x root 3. So let's go ahead and solve for our x in this situation. So x root 3 is equal to the square root of 6. To isolate our x, we divide by the square root of 3. And we get that x is equal to the square root of 2. So we can label that here, square root of 2. We know that f is equal to 2 times x, which is just 2 root 2. Now in my other triangle, I can use 30, 60, 90 triangle proportions to solve. So from solving our first one, we know that this is the square root of 2, my hypotenuse. If this is 30 and this is 60, we're solving for h, and your hypotenuse is 2 times h. And your side across from your 60 degrees is h root 3, which is technically g. We know the hypotenuse is the square root of 2, so let's go ahead and use this to solve for h. 2 times h is equal to the square root of 2. To isolate that h, we divide by 2. And we get that h is equal to the square root of 2 over 2. Now, we know that g is equal to h times the square root of 3. So g is equal to, okay, we know h is root 2 over 2 times the square root of 3. Well, the square root of 2 times the square root of 3 is the square root of 6, all divided by the square root of 2. They're both not under square root, so we can't simplify. So that will be my final answer. So if we list those out, we get that f is equal to 2 root 2, h is equal to the square root of 2 over 2, and g is equal to the square root of 6 over 2. Awesome job. So now what I'm going to have you do is you're going to take a moment and you're going to apply what you learned here to your homework. So on your homework tonight, I want you to work through, see what you know, see what you don't know, and then we are going to practice this more on